Now let's head back to our fish type objects. So what exactly is an index? It's simply the position of an element within an object. Yes, it's that straightforward. This position is usually represented by a number. Let's take a look. We have 1, 2, 3, 4, 5. So the position of catfish is 2, salmon is 5, and mackerel is 1. Essentially, indexes are numbers that pinpoint the position of elements in a vector or any other object. This isn't just limited to vectors, it applies to all the data structures we have in R. So how does this help us access elements within a vector? Let's use our fish type example. To access elements, we use square brackets. Inside these square brackets, we simply pass the index number. Since we have 1, 2, 3, 4, 5, if we want to get tilapia, we'd input 3 inside the square brackets. And there it is, nicely printed. An interesting thing is that you can also perform other operations on that. For example, here tilapia is converted to uppercase. This small operation is called nesting, but let's move on from that for now. We can also access other elements. Let's say we want to access catfish, and there you have it, catfish. Alright, now for a quick exercise. I'm going to give you a list of laptop devices. I want you to access the Asus laptop from this list. Okay, I hope you got that right. To get Asus, we use the square bracket. Now let's find the position of Asus. It's 1, 2, 3, 4, 5, 6, 7, 8. So 8. And there we have Asus. This is one drawback of counting things like this though. If we have a very long list, it will take forever to find the index position we want. Luckily, we can use the which function. The which function will tell us the position of Asus directly. And there it is again. You simply take these and wrap it inside the square bracket and it's nicely printed, since this gave us the index. What if we want to access more than one element? Often, we are not just interested in a single value but multiple values. This is a common scenario in research, where we are investigating several things simultaneously. There's no real trick to it. You actually already know how to do this. And that's what makes this so interesting. Remember the C function, which is used to combine values. We can use that to combine index positions as well. For example, if we want to get HP, which is position 1, MSI, which is 3, and Lenovo, which is 5, we can pass in 1, 3, 5. Or perhaps Asus, which is 8, Apple, which is 12, and Samsung, which is 9. You can simply pass the combined list into the square brackets. So I'll copy this and paste it into the square brackets. And there you have our values printed out. That's quite easy. These are the basic methods you need to access elements. Next up is modifying elements of our vectors. Modifying elements is similar to adding new one. You can both add and change elements. Finally, we'll cover how to remove elements. I'll create 3 sections to cover each of these operations. So, to add elements, there are 2 main ways. First, we can use the square brackets. For example, we can take our fish type and add herring to it. Herring is quite a popular fish in Europe, especially in Denmark. I love it. It's a classic fish, but in Nigeria, it's simply called kpanla. Yes, I think that's kpanla or shawa in Nigeria. One of the two. Now we have the fish type. When using square brackets, you always want to assign to a new index position. We currently have 5 fish types here. So we had a new one, making it 6. We simply pass in the name herring, and once we press enter, you'll see it appear. If we type fish type, you see that herring has been added, which is quite nice and straightforward. However, if you have many elements, like in our laptop brands example, adding another one can become a bit tricky. It's not always easy to know what the next available index is. So another way to use the square bracket is to next a simple operation within them. We'll take our fish type, then get the length of fish type, which is now 6, and we will add 1 to that length. This operation will automatically determine the length of fish type and then add 1 more to it. This is quite easy. as we are always adding one more element to the very last position. Now we'll add the boa fish, and it's nice because you will see it's automatically added to the last place. So now we have boa fish. The second way to add elements is to use the append function. The append function is quite user-friendly. It actually has three parameters. If you press tab within the parentheses, you will see them. X, which is the object, values, which are the new value or elements you want to add, and then after, which is the position where you want to place the new element. So we'll use fish type and add a new fish, this time eel. I haven't tasted eel myself. Then we'll say it should come after position 2. Once I press enter, we see we have mackerel, catfish, and then eel comes after catfish, followed by the other fishes. Interestingly, it can also take in multiple values. We can simplify this function by just passing the object we want to alter, which is fish type, and simply pass the value. What this does is it automatically places the new value at the very last position. So we had fish type, and again, you will see it right here. Now, you might be a bit surprised why fish type isn't changing permanently. This is because the append function doesn't alter the original object element unless you reassign the object. Yeah, for fish type, we are using the square brackets to reassign to fish type. There's one key difference between these methods. The downside to using the square brackets for adding elements is that you are likely to get missing values, represented as NA in R. This happens if you input an index that's far beyond the very next index position you're supposed to fill. Let's take this as an example. We'll put 14 as our index number and assign A to it. And once we type fish type, we'll see that we have these NAs and then A. We're almost done with vectors now. Next is altering vectors or changing the elements within them. If we print our fish type object, you'll see we now have NAs. It's a good idea to replace these NAs or missing values with actual fish names. To change an element of a vector, but this time we put the index number of the particular element we want to change. Let's check the length of fish type. It's 14. If we want to find out which particular indices have the NAs, we can use which is .na and fish type. We have 8, 9, 10, 11, 12, 13. So these are the numbers with the missing values. We are going to replace this. To change the elements at index number 8, we simply pass the index number into the square brackets, of course. Then we assign the new value to it. This time we'll assign the fish pike to it. And if we print fish type, you will see pike here. You can also change multiple elements at once. I will change 9 and 10 while you change the rest. I'll give you a list of fish you can use. Okay, I hope that went well. To do this, we take the fish type object and we pass the index numbers into the square bracket. In this case, it's 11 to 13. We assign the following values to it. We have the bluegill. Okay, there's an error. And here we go. So I typed in fish type and we've done a great job. We successfully replaced all the missing values and altered them. We can also alter other ones. Let's say you want to remove the cod because you don't like cod. Take fish type, cod is number 2. Of course, you can use which as well. I think this is safer. If fish type is equal to cod, we replace it with cap. Then we check our results. You'll see the cod has been replaced with cap. Now, the last thing we'll do with our fish object is to remove some fish we don't like. I'm going to remove all the fish types I haven't tasted out of all these. To remove objects, we also use the square brackets, but this time we use the minus sign or the dash. This indicates that we want to remove a particular item. So we pass minus 12. If we remove 12 here, you'll see that the element puffer has been removed. You can also use C function to combine values and remove multiple elements at once. So minus C, 12, 11, 13, 14, 10. You see that they are all removed, just like that. This brings us to the end of this lesson. I hope you enjoyed it. See you in the next lesson. where we will discuss matrices.